Okay, so here we have a container with only helium in it. So here's our container. At a pressure of 544 torr and a temperature of 35 degrees Celsius. Then it tells us that neon is added to this container and the pressure increases to 959 torr. And we want to calculate the grams of helium in the container. So the way we want to approach this is we want to use the ideal gas law. And we know that for any gas, PV over NT is going to equal a constant. So that's R. So we know that since we have the pressure of helium times the volume of helium is going to equal the mole, or is going to over the moles of helium times the temperature of helium equals R, right? Well, then that's also going to equal the pressure of neon times the volume of neon over the moles of neon times the temperature of neon. So what we're really looking for in grams of helium is we need to solve for moles of helium. So then the question is, do we know everything else? Okay, so let's see if we can figure this out. The temperature doesn't change. There's no mention of a change in temperature. So what that means is we're going to cancel out the temperature of both of them. You'll also notice it says container, and it doesn't say anything about the volume of the container. So we're going to assume the volume is constant, okay? So that means that the volume of neon equals the volume of helium, because a gas always fills its container. So we can get rid of the volumes of helium and neon. So what that leaves us with is, and let's solve this for moles of helium, that the moles of helium are going to equal the pressure of helium, so we're rearranging this equation, times the moles of neon over the pressure of neon. Okay? So do we know all those things? What is the pressure of neon? Do we know that? Well, it says the pressure increases to 959 torr. So the pressure of neon isn't 959. It's 959 torr minus 544 torr, which is the pressure of helium. So the pressure of neon is 415 torr. Do we know the pressure of helium? Yes, we do. It says it's 544 torr. Okay, do we know the moles of neon? Well, we were given that there was 0.810 grams of neon, so we can convert that to moles. And then we'll plug that into our equation. Okay, so the moles of neon are 0.0401, moles of neon are 0.0401 moles. Okay, so now we can go ahead and plug everything in here. We can take our pressure, which is 544 torr, times our moles of neon, which we just calculated, which is 0.0401 moles of neon, divided by the pressure of neon, which is 415 torr. That's going to give us the moles of helium, which comes out to 0.0526 moles of helium. Let's change that to grams. And what we get is 0.210 grams of helium. And that's our answer. Let me just suggest that when trying to solve problems like this, we try to start with PV equals nRT when we're dealing with moles. And usually we're having two gases, so we can set everything equal to R, and then we know that our two gases, the PV over NT, will be equal. That's going to be the case for any gas because R is a constant.